Hello, boys and girls. You are watching Burmanation Station 1.4. We're talking on lesson 10.3 today, operations of radical expressions. But before we start, I have a challenge for somebody who is willing to step up to the plate. This little device here is a brain teaser. First person who can show me how to do it and does this before or after school earns a prize. Good luck. All right, let's get moving. These are the warm-up problems that we worked on over the last couple days. If you need to check over those things, go for it. And we're going to get started with what we last learned, which was from 10.2, how to simplify. We're now going to be able to add and subtract radical expressions and be able to multiply radical expressions. It's going to be good stuff. For the most part, folks, all we're really looking for is, do we have like terms? Do they have the same square root? That is how we determine that we can add 6 root 5 plus 2 root 5 minus 5 root 5. So we end up just adding or subtracting the number in front of the square root. So 6 plus 2 becomes 8. 8 minus 5 becomes 3. So we're really just doing 6 plus 2 minus 5, getting our answer of 3 and keeping the square root of 5. That's, for the most part, all we have to do here today. So let's do another one really quickly. Notice that we have square roots of 2 and 11 and 11 and 2. So my like terms are going to be this guy and this guy, and then these two will go together as well because they're both square roots of 11. So 7 minus 6 becomes a square root of a 2, and then 8 root 11 minus 4 root 11 becomes a plus 4 square roots of 11. So there we go. Moving on again. All we're again doing, folks, is we're adding together our like terms here. We have a 3 plus 4 is 7. 7 minus 2 is 5. Root 13. And here's your multiple choice to show that you know how to do those things. And now we're going to move on to something a little bit more difficult. Our task is to add or subtract. Now we have unlike radicands this time, so what we're going to do is we're going to simplify our square roots, and hopefully we'll find some that are ended up being the like radicands. So 27 could turn into a 9 times a 3 in the square root style. So the square root of 9 is 3, so just the 27 turns into a 3 root 3 multiplied by that 6, so we have 18 square roots of 3 for just this first part. Now we're going to break down the 12 into a 4 and a 2, and that turns into 2 square roots of 2 times that 8 that was already out there, so we have plus 16 square roots. I'm sorry, this is a 3. Don't tell anyone that I made the mistake. Square roots of 3. Next one we're going to break down into a 25 and a 3. Square root of 25 is 5, so we have a 5 square roots of 3 times the 2 that was already there, so we have plus 10 square roots of 3. So now that they're all the like, we can add 18 plus 16 plus 10. And 18 plus 16 plus 10 is 44 square roots of 3. Pretty cool stuff, huh? Yeah, I thought so too. When we multiply, you hopefully learned this a little bit today, but we're going to take the 2 times 2 root 3 times the 4 root 6. We're going to combine together. 2 times 2 makes a 8. Root 3 times root 6 turns into a root 18. Now because of this root 18 is something that we can break down, we will. Root 18 turns into a 9 and a 2. And the square root of 9 is 3, so the whole square root of 18 turns into a 3 root 2, and because 18 was being multiplied by this stuff before we simplified, it should still get multiplied. So 8 times 3 is 24 square roots of 2. Try that same exact process here, except for you're going to have to distribute this 4 square roots of 2 to both 3 root 2 and the 2 root 6. Now I had some students making fun of me because I say root instead of root. Root. I'll practice. I think we have one more question here to work on. Root. And here it is. So when we multiply 3 root 3 times 5 root 8, we get a 15 square roots of 24. So I pretty much did the 3 times the 5 to get the 15, and the square root of 3 times the square root of 8 to get to the 24. Now the 24 breaks down into a 4 and a 6. Now the square roots of both those items, square root of 4 is 2, and we don't have a nice perfect square for 6, so it stays that way, and we multiply that by what was already there, and that is why our leftover answer is a 30 square roots of 6. So here's the patterns that we're looking for here, folks, to help you out with things. If you would write that down, that'd be wonderful. If there's any questions, make sure you ask tomorrow or type it into the Google response. And again, the challenge has been laid. Can you get this taken care of before school or after school? I'm looking for the first person to come in and show me the correct way to do this without cheating. This is Bermination signing off.